test and set instruction. Okay, so in this chapter, first we have seen the software solution for synchronizing processes, or the software solution for solving the problem of critical solution. And now we are seeing the hardware solution for solving the problem of critical section. Now in the hardware support or hardware solution, we have seen the atomic instruction, that is test and set instruction. Okay, so morning we have discussed this test and set instruction, but in this example that we have seen in morning lecture, the solution provided by this test and set instruction, it is the only related to the mutual exclusion. Okay, this solution is related with the mutual exclusion. Using this solution, only mutual exclusion can be achieved. But the bounded weighting, it is not achieved by this solution. Okay, so for that purpose, we have another algorithm or another instruction in which all three conditions can be met. All three conditions: first condition, mutual exclusion, in which only one process is allowed in one section, in critical section at a time. Second condition, progress, in which if the process applied for the critical section, and if there is no any other process executing in the critical section, then immediately access should be provided that process. That is the progress. And the third, that is by using the third condition is the bounded weighting, which says that if the process is executing, same process is executing multiple times when the other processes are waiting, then it should not be happen. There should be a limited access, limited number time of access to a particular process to execute in the critical section. That is the third. So all these three requirements can be satisfied by using some modified instruction of this test and set. Okay, so remember thing that this test and set instruction, that is provided in the C format, but practically it is a single instruction which is present in the binary form in our operating system. There is only single instruction. This test and wait, this is the single instruction. And similar case here, which this is implementing, this is actually implementing this test and set instruction, but this algorithm is providing the solution, bounded weighting, as well as mutual exclusion. Okay, so before explaining this one, I will discuss another type of instruction, that is the swap instruction, which is also like the test and set instruction, but it is using some different functionality. That is, it is using the two variables. Okay, two variables or two parameters it is using in the swap instruction, whereas in the test and set we have seen that only one parameter is passed. Okay, so swap instruction, it is another instruction that is supposed to solve the problem of critical section, and definitely no doubt this is the hardware solution. Okay, so in the swap instruction, what is happening here? Here two variables are passed, two memory reference are passing, whereas in the test and set instruction only one memory reference was there. But here in this case, two memory reference we are passing, and here we are performing the swapping of two values. What we are doing? We are just performing the swapping operation. I think you know well what is the swapping operation. Okay, here star A is equal to star B is there. Okay, understanding. Star A is equal to star B. Okay, by mistake I think the equal to is not there, but consider that star A is equal to star B. So if we are doing, first we are storing the star A value into the temp, then we are storing the value star B into star A, that is transferring value B to A, and again at B we are transferring the value from temp. So we are doing just swapping operation by using call by reference method. Okay, so value from original location, it is being swapped. Okay, now how to use this swap instruction in your by the process. Okay, actual how this instruction can be used by the process. So here two variables they are using one variable, that is common variable log, which is initially false. Okay, it is not shown here, but between two processes, the shared variable is the log, and initially it is initialized to the false. Now every process will have its local variable, that is key. So whenever any process will enter, it will first initialize its key variable is equal to true. Now it will check the while loop whether the key value is true or not. If key is equal to true, then it will call the function swap. So what is the parameter we are passing here? We are passing log and key, where the value of log it is false, where the value of key it is a true. So after swapping, what will be value? After swapping, log becomes true, and log becomes true, and key becomes false. Okay, initially log is initialized to false and key is a true. Now we are swapping. We are performing swapping. So key become false and log it become true. After performing this, again it will go to the while loop. Perform operation, again it will go to the while loop. Then here it will check whether key is equal to true. But now after performing the swapping operation, value of key is become false. So this will break the loop and enter into the critical section. Now suppose another process arrive. Another process P2 arrive. Now what P2 again it will do the same operation, that is key equal to true, because key is a local variable. So key is a true. Now again it will check in while loop whether the key is equal to true or not. Yes, key is a true. Then it will go to the swap function. Now log is a shared variable. Okay, log it is a shared variable. So value of log it is set by P1 as a true. Okay, in the first attempt by P1, when it performs the swap operation, then the default value of log, which was false, it become a true after performing the swapping operation. So in the next operation that is performed by P2, now the value of log it is a true, because it is a shared variable and that value is set by the first operation. So for the second process, the value of log it is a true, and also the value of key it is also true. So that's why after performing this swapping, again the value of key it will be same as a true, and value of log again it will be same as a true. Then after that, again it will call while function in P2. Again it will check key. Again key is equal to true. Yeah, value of key is true. So again it will perform swap operation and so on. Okay, it will start with this swap operation unless and until the process P1 will complete the critical section, its execution in the critical section, and when the P1 will set log equal to false, then the second process can break the while loop. Are you getting? Or otherwise consider that suppose the complete operation of P1 key is equal to true, while key equal to true, it have to perform some task. Now here key is a true, condition true, come to the swap, swapping the value of log and key. Log is false initially, key is the true. So after swapping, key become a false, log become a true. Again it will check in while loop whether key is a true, but no, after swapping operation key become false, so it will break the while loop for P1. execute the critical section, and after complete execution of this critical section, it will go to the log is equal to false. Then after that, when P2 comes, then it will check key is equal to true. Again, it will check whether key equal to true or not in while loop. It is a true, then it will perform swap operation. Now, already P1 finishes task and it has set the value of log equal to false. So that's why when the operation is complete, value of log is false. So after swapping, the key becomes false and P2 can get into the critical section. Okay, so likewise, the swap operation is used to perform this to solve the problem of critical section. So now here in this state, we can say that we can achieve the mutual exclusion by using this simple algorithm. Any doubt in this? Today attendance is very low. Only 72 students are present, and I think A division 70, B division 79, 149 students is there. 50% is also not present. Okay, any problem? आणखी एकदा रिपीट करायचंय का समजले? Are you getting all of you? Okay, now we can go with the next algorithm, that is implementing mutual exclusion as well as bounded waiting. Okay, earlier we have seen that using this type of state and set instruction or swap instruction, we can achieve only mutual exclusion, but we can't guarantee that the system can achieve bounded waiting. Okay, for example, suppose there are two processes P1 and P2. P2 execute the block, P2 execute the critical section, and again it applies for the lock. Then it depends on operating system whether to sanction the request of P1 or P2. And suppose OS again give the access to P1. Suppose after executing again this critical section, again P1 applied for this critical section, and again suppose OS satisfies this request, then in that case again and again only P1 is getting the access. So this can be happen by using this type of algorithm. So this algorithm, that is swap as well as this test and set, it is not guaranteed that there is a implementation of bounded waiting. Okay, so for that purpose the modification is applied, and after the modification this algorithm is presented. So this algorithm is actually ensuring that all three criteria can be met. That is, this algorithm can achieve, through this algorithm we can achieve mutual exclusion, as well as through this algorithm we can achieve the progress, and as well as also we can achieve the bounded waiting. So in this case, two data structure they are using. Definitely lock is there, which is shared variable, and two more variable, that is waiting and key variable. These two additional data structure is using in this algorithm. Okay, so initially the value of waiting is a false, as well as the value of key it is also false. Both are false, as well as lock is also false. So when process P1, it will it want to execute the critical section, then it will come into this loop, and it will first initialize its waiting parameter as a true. After that, it will initialize the value of key is equal to true. Then afterwards, it will check in while loop that the waiting of I and key, and this condition satisfy when both waiting, that is waiting it should be true as well as key is a true, then only this condition satisfy, and it will call the function test and set, and it will pass the parameter lock. Now as we know that the test and set condition, it is setting the memory location 1. Okay, so it will set the memory location, and the value returned, it will be a false, that will be stored at the key. लॉकची व्हॅल्यू जी असेल ती मेमरी लोकेशन जाईल, लॉकची व्हॅल्यू फॉल्स होती, so it will return to the key. So now key become a false. So again it will go to the while loop, and here the condition is become false. Okay, waiting is true but key become a false, so that's why it will break the while loop, and after that it will set waiting as a false. It will set itself waiting as a false, and then it will enter into the critical section. So this condition is satisfying the both criteria, that is first criteria, mutual exclusion, because when it will enter into the critical section, then other process can't enter into this critical section, because the value of key here what is happening, the value of lock, it become a true, value of lock, it become a true, so that's why other can't enter into this section. Because what is happening in P2, suppose P2 is executing the same, when P1 is already in the critical section, then in the P2 execution it will set waiting variable as a true. Okay, because it has its local variable, so it will set waiting as a true, key as a true, and it will check while loop. So in the while loop, since both are true, it will enter, but in that case the value of lock, it is a true, so it will go in the waiting state unless and until the value of lock is become a false. So the mutual exclusion, it can be achieved, as well as the progress, it is also satisfied. Progress, it is also satisfied. As it requested by the P1, it can enter into the critical section. So this request is also satisfied. Both conditions we can meet. And for meeting the third condition, the next code that is given is the j equal to I plus 1 mod n up to the j equal to j plus 1 mod n. This code is given for limiting the execution of the process in critical section. Okay, this will limit the execution of the process in the critical section. So by using this, you can achieve all three conditions. Okay, so already I have this is the exchange information. So test and set and swap. Current processor is not using the test and set and swap. It is using the exchange information, or we can say today's advanced processor, it supports the exchange atomic instruction. Okay, this is also have the same functionality like test and set, but the name is different. Okay, there is the way of execution. That's how it is performing. This is not part of syllabus, so I will not go through this exchange instruction. Okay, now whatever we have discussed, this paste and set and swap, these all instructions, definitely these are all the atomic instructions. आपण C च्या फॉर्मॅटमध्ये कोडिंग बघितलंय, बट दिस इज फॉर आवर अंडरस्टँडिंग. ऍक्च्युअली सिस्टीम मध्ये ती एक atomic instruction म्हणून सेव्ह असते, and by executing that instruction processor is locking the critical section, or processor can enter into the critical section. Okay, so that is the instruction available in the system. Now this instruction is implemented in a high level construct, and the high level construct that is present is spinlock, mutex and semaphore. These are the high level constructs which are using for the synchronization purpose, and in that construct we are implementing, or we are using this test and set and swap instruction. Okay, so among that, spinlock is not in your syllabus. Mutex and semaphore is there, but also mutex have a very short description, and most of this discussion is regarding the semaphore. Okay, there is actually not much difference. Yeah, this is the code of the spinlock in x86 operating system. Okay, one more thing that I think x86 OS सांगितलं का तुम्हाला regarding x86? आहे का कोण जागा आहे? Okay. Actually, there are very few people which are responding. Okay, like Ankita, Fiza, or Pooja is there. Only 4 to 5 people. बाकीचं एकही जण कधी रिस्पॉन्स देत नाही. Okay, so x86 actually this is the operating system which is designed specially for the teaching purpose. Okay, if we compare this x86 with Unix or Windows or any other Solaris operating system, so all operating system, other operating system, these are the very heavy means from coding perspective. बाकी सगळ्यात OS चा कोड हा भरपूर मोठा आहे, आणि जर आपल्याला OS स्टडी करायचा असेल त्याचा कोड, तर त्या केसमध्ये it is not an easy task to understand the code from Unix OS or Windows OS. Windows चा तर कोड बघता येणार तुम्हाला फक्त बघता येऊ शकतो Unix चा. This is the open source, so you can see the OS code of the Unix system, but it is a very large. फक्त kernel जरी स्टडी करायचं गेलं तरी पण भरपूर कॉम्प्लेक्स आहे. So for that purpose, for the learning or teaching purpose, a special operating system that is designed, it is the x86 operating system. Okay, if you want to do in some detail of coding regarding this x86, so just go to Google, yeah, and you can type in Google that is x86 operating system source code. You can get all the source code of this OS at GitHub. I think मला तर सगळेजण GitHub यूज करत असतात. तर GitHub मध्ये OS चा हा सगळा कोड इथं प्रेझेंट आहे. सगळा कोड आहे. जेवढं काही आपण सध्याला टॉपिक कव्हर करतोय त्या सगळ्या टॉपिकचं ऍक्च्युअल इम्प्लिमेंटेशन, आणि ते पण एकदम स्मॉल ह्याच्यामध्ये शॉर्टमध्ये, हे सगळं तुम्हाला त्यामध्ये बघता येईल. And I think only the 8,000 lines of code is there. Okay, as compared to other, it is very low. So if anybody interested, he can study or he can see the real core of the OS from the GitHub. Okay, GitHub ला सगळा कोड आहे प्रेझेंट तिथं. Okay, for example, this is the main.c. Main function is there, so you can see here inclusion of all header files, especially xv6, x86.h. Okay, in this you can see the calling of this function as well as, okay, first there is a page allocator, then kernel page table. So likewise, okay, you can see, you can check this whole code. सिंपल आणि शॉर्ट मध्ये आहे. आता बायसचा कोड इथं आहे का, बूटिंगचा एखादा कोड जर असेल, हा स्पिनलॉकचा आहे, spinlock.c, spinlock.h. सो आत्ता जो कन्सेप्ट आपण म्हणजे तुमच्या ह्याच्यामध्ये नाही आहे, बट स्पिनलॉकचा कोड इथं तुम्हाला मिळून जातो. ह्या ओएस मध्ये they are using the high level construct, that is the spinlock, and using spinlock they are implementing hardware solution for solving the problem of critical section. हाँ इथं आहे बूटिंगचा. बूटिंगचाच आहे का हा? Yeah, this is the code for the booting. Okay, here you can see the sector size defined as the 5112 bytes. Memory layout header file is also including, and initially setting the reading the first page of the disk. Okay, so likewise you can see or you can refer the code of OS from this side. Okay, this is the additional. It is not definitely extra तुम्हाला जे काय सांगते त्या गोष्टीचा तुमच्या युनिव्हर्सिटी एक्झामला फायदा होणार नाही. क्लिअर? ओके, पण दिस इज द फॉर एक्स्ट्रा नॉलेज. बाकीचं तुम्ही एक्झामला तुम्हाला प्रिपेअर कसं व्हायचं मला वाटत नाही की मी सांगायची गरज आहे. 14 वर्ष झालं तुम्ही तेच करताय, 14-15 वर्ष झालं. हाऊ टू पास एक्झाम, हाऊ टू राईट द एक्झाम, यू नो वेल. I am not interested to teach all these things. Okay, we'll stop here. In the next lecture, we'll start with the semaphore.